Hello friends, in this video today we're going to discuss about refraction through a prism. This is a topic of class 12 physics, ray optics. Okay, so here we need to show that the refractive index of a material of prism is given by this equation. N21, that is equal to N2 by N1, is equal to sine of A plus dm by 2 by sine A by 2. Okay, and also we need to show that for a small angle of prism, dm is equal to n21 minus 1 into A. Okay, this question was asked in HS final examination 2024 under Assam Higher Secondary Education Council, right? So now let me show you how to answer this question. Suppose this is a prism and this is incident ray of light. Suppose, let me properly, this is the incident ray of light. Okay, and after refraction it passed through this part, and let me draw the normal here. Just give me a second. So these are the two normals here. Okay, right. So now you see, this is the light and this is the actual part of the light. This is the direction of the light. Okay, but after refraction it bends, then again after refraction it bends away from the normal, right? This is the normal. Suppose this is n1 and this is n2, right? Okay, so when it is traveling in rare medium and enters in the denser medium, then here you see it bends towards the normal. This is the normal, right? It bends towards the normal, and when it is going out from this denser to rare medium, then it is bending towards the away from the normal, right? So hope you have understood this. Now you see, this is the angle of incidence I, and this is angle of emergence, and here angle of refraction r1, and here is the angle of incidence r2. Suppose, let me draw the figure clearly. Okay, here you see this is the incident ray, angle of incidence, this is the normal n1. Okay, angle of refraction r1. Then again in this prism, here you see it is again incident at this point. So here let me take this angle as r2. Let me write it r2. Okay, so sorry, r2, and this is the angle of emergence e. This is the normal n2. So this is one normal, this is another normal here, and so here is the original direction, right? This is the direction of the incident ray, and it is deviated by this angle, right? Deviated through this angle. Let it be delta. Suppose, let it be delta, and this is the angle of the prism. Let the prism be ABC. This is the angle prism ABC, right? So now here the question that I have given here, this, you see this question, this refractive index of the material of the prism is n21. What does it mean? Actually, suppose this is the prism, and refractive index of this prism, material of the prism, is actually n2, and the n1 is the refractive index of the medium, whatever be the medium. That means where this experiment is done. Okay, that means it may be air or it may be done in water, right? So that is the refractive index of the medium. That means, okay, surrounded by the by which this medium is surrounded. Okay, this prism is surrounded. Okay, so that's why actually it is relative refractive index actually. Okay, so hope you have understood this. So now let me go back to the diagram. So now you see, let us take this triangle. Let me take this point is suppose P, and this point is suppose Q, and this point is R. Now you see, from the triangle APQ, from this triangle, from triangle APQ, so here you see in this triangle APQ, Now here you see this angle, here you can see this one PAQ. So this is gonna be equal to 90 minus R1, because you see this is normal here, okay, so that's why it must be 90. And this angle, you see this angle is R1, so that's why this angle must be 90 minus R1, right? Hope you have understood this. So here you see, suppose this is the normal at this point P. Suppose here you see this is the suppose normal, this is the normal, suppose, okay. So then this angle is 90 degree and this is R1, okay, this is R1, this angle, only this angle, okay, and this angle is 90, so this must be 90 minus R1. Similarly here we have another perpendicular here, okay, so this angle is R2 and this is 90, so that's why it must be 90 minus R2, right? Hope you have understood this. 90 minus R2, okay. And we let me take this measure of this angle is A simply. So we can write angle A plus 90 minus R1 plus 90 minus R2, sum of the three angles of a triangle is 180, right? So that's what we can write. So let me clean this first, okay. So we have got this relation, and from here what we can do, you see this 90 plus 90 is 180, cancel by 180, so A minus R1 minus R2 is equal to 0, right? So A will be equal to R1 plus R2. So this is suppose equation number 1. Now you see for minimum deviation, for minimum deviation, okay, minimum deviation, that means the angle of minimum deviation delta, that must be equal to dm, which is angle of minimum deviation, okay. So in that case, now you see, let me draw a graph. If you draw the graph of angle of incidence and angle of deviation, you will get this kind of graph you're gonna have, okay. This is not exactly parabola, don't think that it is a parabola. So it is a graph. Here we're gonna get delta, here it is angle of incidence, okay. So now you see, if you draw this line parallel to the axis I, then at these 2 points, if this is the angle of incidence, okay, then this corresponding point on this side will give you the angle of emergence. If this is I1 and its corresponding angle of emergence will be E1, okay. So that's, now if you go down like this, at a point here you're gonna get angle of incidence is equal to angle of emergence, okay, and that gonna be the minimum angle of deviation dm, okay. And that angle of minimum deviation, it is possible when angle of incidence is equal to angle of emergence, okay. And one more condition, this R1 will be equal to R2 in this condition. So this is suppose equation number 2. So why R1 equal to R2? Let me explain here, you see. So now you see, so here we're going to consider the medium surrounding the prism of refractive index 1. Again it is refractive index 2 and refractive index, here it is N1, okay, right. And this is the prism, okay. So as the refractive index of prism is given n to 1, what does it mean? Actually this is the refractive index of the material of the prism with respect to the medium by which it is surrounded, right? Hope you have understood this. So if you take the absolute refractive index, it must be n2, it must be n2, and n21 is actually n2 by n1, right? Hope you have understood this. Now you see we already know according to Snell's law, suppose you have a medium of refractive index n1 and you have another medium refractive index n2, and if light comes from n1 and the incidence angle of incidence is I, right, angle of incidence is I, and refracted through the second medium like this, and this is the angle of refraction. In that case, by Snell's law, we can say that n1 sine I is equal to n2 sine r. Also you can write like this also, sine I by n2 by n1 sine r, and n2 by n1 means n21. You can write n21, but now we are not going to write this one because now I am going to show you how I have got this r1 equal to r2. So in this case, if you consider the case of the prism, if this is the prism and here is the incident ray and this is the normal and this is the angle of incidence I, and the angle of refraction in this case, this is r1, right? So this is the refractive index, this is the medium of refractive index 1 and here refractive index 2. So in this case, so here the relation will be n1 sine I, n2 sine r1, right? Similarly, you see, if you we have a normal here as well. Okay, now let me make it enlarge. Okay, now you see, this is the incident ray and it goes this way after refraction. Okay, this is angle of incidence, this is r1. Again it strikes at this point, at this phase. Okay, this is the medium of refractive index 2, again it is refractive index 1, here it was 1. Okay, now if you draw this normal, this angle r2 is the angle of incidence for this phase, ASC phase. Okay, and this angle of emergence is the angle of refraction now. Okay, so when light was moving from this medium of refractive refractive index n1 to refractive index n2, we have got this relation. Now we are considering the case light traveling in this prism from from the medium of refractive index n2 to the medium of refractive index n1, and angle of incidence in this case r2, and angle of refraction is the angle of emergence E. So in that case, if we write the relation, then we're gonna get n2 sine, instead of I we're gonna write r2, and n1 sine, instead of r1 we're gonna write angle of emergence E, right? So hope you have understood this. Okay, so now let me clean these things. Now you see, as we have got we know that for minimum angle of deviation I should be equal to E. So in that case you see, this term and this term must be equal because I equal to C, right? So we can replace this by n1 sine I, since because we are going to show that in case of for minimum angle of deviation r1 must be equal to r2. So that's why, and also we know that for minimum angle of deviation I must be equal to E. So since I is equal to E, so we can replace this E by I. So that's why we have got this relation, right? Now you see, this term is this one, this is equal to this one, so we can say this term is equal to this one, right? Hope you have understood this. So from these two equations, from these two relations, you can see, so we have got n2 sine r2 is equal to n1 sine I1. Here also we have n1 sine I1, sine I, not I1, is equal to n2 sine r1. So here you see these two terms are equal, so that's why these two terms must be also equal, right? Hope you have understood this. So that's why we can write that n2 sine r2 is equal to n2 sine r1. So n2 gone, so we have got sine r2 and sine r1, so that means r1 must be equal to r2. That's how we have got this, okay. But in in this derivation you don't need to show how you have got R1 is equal to R2. Just you write this condition as you have we're gonna consider that this condition is known to us, okay. We are not going to show these things, okay, how we have got this. Just for better understanding I have explained these things, okay. So hope you have understood this. Now let me clean these things and let me proceed further, okay. Now you see let me mention here this relation we had got from this triangle APQ, right? Let me mention that from triangle APQ, okay. Now you see as R1 equal to R2, so let me consider that R1 equal to R2. So since these two are equal, so let me write something here. Let me consider both equal to R. Suppose both equal to R. Let me consider that way. So this is equation number 2. Okay. So now we can replace R1 and R2 by R. So we have considered that this is equal to R. Let's see. Let me write that way. Right. So now using 2 in 1 or from 1 and 2, what we're gonna get, A is equal to R plus R, so that means you can write twice R, right? So we have replaced this R1 by R, replaced this R2 by R, okay. So let it be equation number 3. Now you see, we know that exterior angle of a triangle is equal to the sum of the two opposite interior angles, opposite interior angles. That's why you see, if you consider this triangle, now you see this triangle here, you can see this triangle. So this delta is the exterior angle, so that's why it must be equal to the sum of these two opposite interior angles, right? So that's why what we can write here, you see. So let me tell you one more thing. Here you see this angle is I, then this angle must be also I, right? Because these two are vertically opposite. Hope you can recognize this. You can see these two lines, so these two angles are vertically opposite, right? So that means you can, let me show you here, okay. So if you concentrate here at this point, you see, so this is the normal N1, and this is the angle of this is the incident ray, and this is the angle of incidence I, okay, and this is the refracted ray, and this is angle R1, okay. Now you see this angle must be vertically opposite to I, so that's why, so this angle must be also I. If this angle is I, then this part of this angle, this upper angle, which is above this refracted ray, that must be I minus R1, right? Hope you have understood this. So that's why here you see this angle we can write here, this is I minus R1. Similarly this angle, you can see this angle will be, now you see, let me tell you one more. This angle is vertically opposite to this. So if this is E, then this must be also E. If this is E and this angle, here you can see this angle is R2, then this angle must be E minus R2, right? Hope you have understood this. Let me explain again. So this is the normal, you can see, and this is the this is the ray, emergent ray. So these two angles are vertically opposite. These two angles are vertically opposite, and this angle below this ray of light, this is R2. So the above the ray of light, we're gonna get E minus R2, right? Hope you have understood this. So now let me clean this figure. Okay, sorry. So that's why this angle must be E minus R2, right? E minus R2. Let me write it. E minus R2. Okay. Now, in this triangle that we have got now, this is the angle of deviation delta, right? And this angle is I minus R1, and this angle is E minus R2. And these two are the opposite interior angles of this triangle, and this is the exterior angle, right? So that's why we can write that delta is equal to I minus R1 plus E minus R2, right? Hope you have understood this. This angle, you can say this angle is I minus R1, right? Let me explain it again properly. Let me clean this graph here. Okay, let me clean this graph. Okay, so here you see this is the angle of deviation delta. So this angle we have got I minus R1, and this angle we have got E minus R2, and this is the exterior angle, and its opposite interior angles are this one and this one. So this must be equal to sum of these two, right? So hope you have understood this. Now in case for minimum angle of deviation, that is delta is equal to dm, in that case here you see what we can do. We can replace this R1 and R2 by R, okay, right? So when delta is equal to dm, that means angle of minimum deviation, then we can write that I minus R plus E minus R is equal to, because in this case this R1 and R2 both equal to R, in this case we can write this is equal to dm. Okay, now you see what we can do. What we have got, I plus E, then minus R minus 2R is equal to dm, right? That's what we have got. Okay, now again here you see from equation number 2, I is equal to E, so we can replace this E as well. So we can write I plus I, so that's why it's going to be twice I. So using equation number 2, right? Hope you have understood this. Now you see from here we can say that this twice R, from using this equation number 3, you can write, what you can do, you can replace this twice R by A. So you can write 2I minus A is equal to dm using equation number 3, and this implies that A is equal to 2I minus dm, right? Sorry, let me write this way. 2I is equal to dm plus A, and then angle I must be equal to dm plus A divided by 2. That's what we should get, right? That is I. Okay, now let me copy this relation and let me go to a new slide. Okay, so let me copy this, and here is the last step we have got. Okay, and let me copy the diagram as well. So here is the diagram we have. Okay, now you see, let me clean this. So refractive index of the material of the prism is n to 1 relative to the medium surrounded by which it is surrounded. So according to Snell's law, we can write that if the medium surrounding this prism is n1, refractive index n1, and the material of the prism is n2, then again n1. So in that case here, if we consider only refraction at this surface, we can write the Snell's law like this: n1 sine I is equal to n2 sine r1. Since I have already told you that for minimum deviation I1 equal to R2 is equal to R, so that's why we're gonna replace this R1 by R only, simply. Hope you have understood this. That's what we get, and this equation can be written this way, right? It can be written this way, and n2 by n1 means we can replace n2 by n1 by n21, right? Hope you have understood this. Hope you know these basic things you have already studied, right? So I have given the link of the playlist of all the optics lectures, okay, in the description box. So it's in every video from starting, okay. So if we have got this, now what we can do here, let me go back to the previous slide. Okay, now you see this relation we have got: I is equal to dm by dm plus a by 2. So we can replace this I by this relation, right? So instead of sine I, what we're gonna write? We're gonna write dm plus a by 2. Okay, this is suppose equation number 4. This is equation number 4, and n21 sine r. So r, you know from this relation, you can see this relation from equation number 3. It can be written r is equal to a by 2, right? So we can replace this r by a by 2 using 3 and 4, using equation number 3 and equation number 4. That's what we have got. Now n21 is equal to what we can write: sine dm plus a, this is divided by 2, okay, divided by sine a by 2. That is what we are asked to prove, right? And or you can write this way also: instead of n21 you can write n2 by n1 also. And you see, for a for a prism of small angle, that means if angle A is very small, okay, if A is very small, okay, that means for prism of very small angle, in that case you can sine a by 2 can be written as a by 2 for small angle A. Similarly, the sine of dm plus a by 2 also can be written as dm plus a by 2, right, if the angle is very small. So that's why we can write this relation in this way, that n21 is equal to dm plus a divided by 2 by a by 2. Here 2 gone, so we have got n21 dm by a plus 1, right? If you divide this one and this one by a, you're gonna get this one. So which gives us let me take a new slide. Let me copy this new slide. This is the last step, okay. So from here what we can show, so now here you see the question: for a small angle prism we need to show dm is equal to n21 minus 1 into a. That's what we need to show. Let me show you this one. Here let's multiply both sides by a, then what we're gonna have, okay, just give me a second. We can write this one as dm by a is equal to n21 minus 1, then dm gonna be equal to n21 minus 1 into this is the required relation for prism of a small angle. So this is the required relation for small angle prism, and this is the relation we have already showed here. So let me show you this one, okay. So hope you have understood this. So now let me give you the handwritten notes. Here you can see. So this is the handwritten notes, first page. Okay, and hope you can recognize what I'm writing. If you can't recognize what I'm writing here, then you can send a message to this so that I can send you the PDF of this lecture. This is the first page of the handwritten notes, and here is the second page. Okay, and here is the third page, and this is the fourth page. Okay, take the screenshot. Let me show you one by one again. This is the first, second, third. Pause the video, note it, or you can take the screenshot. And this is the fourth. Okay, so thank you for watching. See you in the next video. Bye bye.